This is something we did on an assessment recently, and the scores still weren't very good, so I want to go through this again real quick. If I ask you to evaluate a definite integral using a limit on RRAM. Alright, so this kind of seems like an oxymoron because I'm asking you to evaluate using an approximation method. But the key here is we're doing what? Yeah, we're going to use infinitely many rectangles. Alright, so to do that, we have to use a limit as the number of rectangles approaches infinity. I'll just use that example I had up there. So the integral from 0 to 1 of x squared with respect to x. If we want to evaluate that, first of all, we're going to use an equal sign. At this point, we could say approximately equal to and find an approximate value using RRAM n. I think the simplest thing, though, from the very beginning is just put the limit on there. Okay, that'll make things the easiest as far as identifying all of your work and then identifying your answer. So it's going to be the limit of RRAM n, which the formula looks like this. You guys probably have this memorized by now, right? What is this? Okay, so for this particular example, delta x is what? 1 minus 0 over n, which is 1 over n. What's wrong with what I just wrote? It's unidentified, right? Make sure you identify all of your work. Delta x equals that. Okay, so plugging in everything that we know into this formula right here, f of x is going to be x squared. Delta x is 1 over n. A is 0. That's the lower limit, right? So we get the limit as n approaches infinity of 1 over n times the sum, I equals 1 to n, of 0 plus I over n squared. So this is just I squared over n squared, right? Yeah, that n squared on the bottom, that doesn't depend on I. So we can factor that out, and we get the limit as n approaches infinity of 1 over n cubed times the sum from to n of I squared. And then I'll always give you these formulas if you need them. Does anybody remember the formula? Yeah, you're on the right track. N times n plus 1 times 2n plus 1 all over 6. So this is a limit that you actually could use L'Hopital's rule to evaluate if you wanted, because if we plug n in, we get infinity over infinity, right? But I'm not asking you to use L'Hopital's rule here. To do that, you'd probably want to multiply this whole thing out, and that would be more work than what's necessary. So what I'll actually ask you to do here is just evaluate it using the trick that we know. So on top, what do we get? We have n times 2n, so the leading term would be what? 2n cubed, and then on the bottom we have 6n cubed, so we have 2n cubed over 6n cubed would be 1/3.